How do we get rid of,
Okay, it's recording.
how do you, oh, you can move this up,
Okay, will you advance right here, right? Shift.
to
no.
left and right, you can hit the.
Oh, here, the
arrows.
arrow, yeah.
Hit the arrows.
Okay.
All right, how do we, all right, John, I need your help again. How do we get this out, so? How do we get that out? Like the way you had it. So you need to reshare.
Thanks. Hide video panel, hide media controls. There we go.
All right, now everybody gets it. Okay,
Did everybody see the screen at home?
Yes.
Okay, all right. All right, okay, I might as well start it, and sorry for the technical difficulties, and finally we'll get this working. Ken just mentioned to me that being a longtime member, if I remember correctly, 40 years ago this month, I gave my first talk about astrophotography using the film. And I remember I came in with the big box there. Inside the big box, I have a hypersensitized kit where you can speed up the slow film, black and white film, 2415 technical pan. And I brought in the chamber, the gas cylinder, the hose, the hand pump, the thermometer. I turned the classroom into a laboratory. You know, yeah, John?
What's film?
2415 black and white film. So anyway, and the last talk I did was 3 years ago, and I was talking about the upcoming Mercury transits in November 2019. Okay, that was my last talk. But before I get into the tonight topic, I just want to briefly wrap it up about the transit that we saw in November 2019.
Right arrow key probably.
How do you advance this?
click on. Here, first click on that and then
Oh,
make sure it's focused. The focus has to be on.
okay. Okay, briefly, we got a gathering at the morning of November 11, 2019 to observe the transit of Mercury from Captree. And we all gathered in the parking lot with a beautiful sunrise that we observed. And it wasn't a perfectly clear, crystal blue sky, but it was just good enough. It was just scattered high clouds around. And here's some of the ASCII members. If I remember correctly, I believe that Joe Markowitz, right, Joe? I don't know if you can hear me, but so yeah, we all set it up, and and some of the members, and we have John back there, Jason back there, Ed, and Tom Panino, and we'll all get together and watch the transit of Mercury, and it's all the crowd. I think it's someone from the AOS member. Doug again with the 8-inch telescope. There, and we're all together around, we're waiting for the transit, and a call, and his mother. So we're able to watch the transit, the beginning of the transit right after sunrise. And more people got around. Okay, and that's Steve and down, here you are. Okay, all smiling, all waiting for the transit. And it's not the same laptop with this? Oh, it's a different one. That's the same one?
That was a good one.
It's a good one, right? It's a good one. Okay. All right. So it's those guys again, all happy and all have everybody had the scope and all. It was a beautiful morning. It wasn't too cold for as November standard. It was really nice. So, and there's some members here. I believe that Bill Bradley.
Correct.
No? Yeah, okay, here's some, okay, now what it looked like through the telescope, now what we saw, what we see through the eyepiece. Well, there it is, at the beginning of the transit, it's nothing but a black small spot, but it has a lot of meaning, it means a lot when you're looking at the planet Mercury. So that's what it looked like through the eyepiece. Now they have beginning This is probably around 8, 12, 50 AU. That's about 10 to 8 in the morning. So the transit started around 7:30ish, 7:35, 7:40, if I remember correctly. And so we can watch it slowly move across this. I mean, if you look at it, at one moment, then you turn around and then 5 minutes later, you can actually see it move to the different areas. So that's pretty cool though. So there was no sunspot. So Mercury was the only spot that you see on the sun. Well, maybe, I don't know. There were a few smaller spots, but nothing significant as I compare with the Mercury and all. So this is around mid-transit. Okay, so you can see it almost to the center of the sun. So this is straight course. Okay, I went home toward the end of the transit. So I able to image the transit through the H-alpha filter. And yeah, well, it's what it looked like. And then right before the transit ends, it came very close to the limb. So that's a very interesting part to see watch across the sun's limb. And I have a sequence of images. I don't know how clearly you can see, but on the computer monitor, you see a lot clearer. You can see on the edge over here, you can see the time. Only 30 seconds later, it moves here. And then once you leave the sun's limb, you still see Mercury against the sparkle through the H-alpha filter. And it's right along the sparkle, and it's too late to see, the black dot there. And I made a short animation that you can able to see.
Oh, wow.
Very cool.
Yeah. And even though the transit ends, you still can see it right over here. Okay. Now, if you remember 2016, we had another transit of Mercury. And again, November 29th, November 2019. Well, you think that's the difference. It's 3.5 years apart. But I really want to show the difference is the two sides, 2019 and 2016. Now, if you look carefully, you can see Mercury, that this is the same scale, same setup, same telescope, same cameras, same setup. And you can notice that Mercury transit is a little larger than the 2019. Okay, the reason for that, during May 2016, Mercury was furthest away from the sun, reaching a aphelion point. And as well as the furthest away from the sun, yet it's closer to Earth. So during the transit, it appears larger. Now, in 2019, Mercury was perihelion, which means that the closer point toward the sun, and yet it's further away from us. So Mercury appears a little smaller. And you can see the difference here, the same scale here. And I think the scale is on 10 arc-second diameter, and this is 13 arc-second. So you notice a little difference, that's much larger. Okay. Usually Mercury has about 13 transits every 100 years. So if you figure you lived to 90 years old, probably you would see 10 transits. Wrong, it does not work that way. You're going to consider a lot of factor in with the location, the weather, and sort of many things. If you see the transit of Mercury 3 to 4 transits in your lifetime, you're very lucky. If you see 5 transits in your lifetime, you're extremely lucky. Because it depends on your location. And so if you take me for instance, the first transit I saw was 1973 when I was a teenager. It was visible right after sunrise. It was on a Saturday, non-school day. And it occurred in November, it was, I think, November 9, 1973. You can see Mercury at the top here. And I was using the solar projector, 4.5-inch Pascal reflector. And I was citing Mercury's right over here, right for sunrise, and just about to leave the disk there. Now, in 2016, the second transit, and there it is right here. And then the third transit, which is last 2019, is right there. And what the next one would be? Well, actually, the next one would be 10 years from now, 2032, but it won't be visible from here. It will be visible probably in the Far East or something like that. But if you want to see the next transit from Long Island, then you have to wait 2049. Now, if I'm lucky enough to live 90, 91 years old, I will see it. So that's what I mean. If you see 4 transits in your lifetime, that's considered lucky. So. Okay, now we'll move on to my topics. What's up with Mercury 2022? I'm just going to wrap it up. You know, what being done, what I did for the past year. And as the Mercury coordinator for ALPO, which stands for Association of Lunar and Planetary Observers, it's the amateur organization. It's the study of the solar system. It consists of planets, the sun, the moon, the meteors, comets, asteroids. So any solar system body is under ALPO. And being as the coordinator, I'm responsible to collect observation, analyze it, and report to the ALPO journal. And I do that in a yearly basis. So, and then usually on the star party like Delphine, I try to encourage people to observe Mercury. But I spoke to one person that he has like I think a 12-inch diode, and it's very interesting in planetary observing. But I try to encourage to observe Mercury. But don't forget, you have Mars, Jupiter, and Saturn are so well observed that to leave Mercury being neglected. Not too many people observe Mercury. There's nothing to see. Well, if I'm going to show you later on, you will see what I mean. And like even Venus too. Venus well observed, but it's some observers think there's nothing to see on it. But to consider Mercury, it's a much challenging object, and it has a reputation of being the most difficult object to observe through the telescope. Now, every 3 months, the ALPO, Association of Lunar Planetary Observers, is published the Solar Astronomical, and this is one of the latest issues, summer 2022. The fall issue just about to be processed. So early this year, I'm pretty sure you remember to see all the planets line up naked eye in the morning sky, and you have Saturn, you have Mars, you have Venus, and you got Jupiter, you got the Crescent Moon. What about Mercury? Mercury, it was visible too, but it was way down there. And I was kind of disappointed that didn't have Mercury included here. But however, we have our own Steve Honda. This is a very fine shot. I believe this is the New York City skyline. It's taken from New Jersey side. And you have Saturn, you got Jupiter, Mars, the Moon, your Venus, Mercury, way down there. And the close-up, there you go. You see after a little white right there. Great. Then you have all planets all line up naked eye in the morning sky. Well, I would hopefully, I wish this can be published in the front page of the Solar Astronomical publication, the one I just showed to you, but it never get around to it. So this is one of the examples that you're trying to get Mercury included in the picture. So, okay, in April Astronomy magazine, April 2022, Astronomy magazine, and one of the author, Bill Chian, called me. I know him personally. He's a very well-known amateur astronomer. He's a psychologist, and he's retired, and he wrote a lot of books about planet Mars. He's a historian. He talked about a lot of histories, observation in the past, or something like that. And he got in touch with me, and I gave him some Mercury information that he planned to write. Now, the reason he planned to write, because one of the famous Italian astronomers, Giovanni Schiaparelli, he was a very well-known back in the late 1800s during the planetary observing, especially Mars. He's a well-known to observe Mars, and he's the first one to record a canal on Mars. Canal, well, that's the Italian word for canal. And of course, he's followed by Christopher Lowell. You see image of Mars with, no, the drawing of Mars was crisscrossing and a lot of double streaks, something like that. And I believe it's, some kind of intelligent being trying to capture the water from the polar cap or something like that. But he made some observation of Mercury too. What you see here, just for example, this was taken from the Messenger spacecraft that orbited around Mercury for 4 years, from 2011 to 2015. And if you blur this up, and you look something like this, but the idea is that Schiaparelli drawing back in 1882, February 1882, we're trying to see if there's any correlation between what we see in the Messenger images and the drawing that he did back in 1882. Now, there's some similarity, like you see a figure 5 shape here, and if you plug the image of the Messenger spacecraft image and it equivalent to the resolution of the amateur telescope, you may able to make it out to 5 here, but it's not definitely true. But it just want to see to verify what he saw to see that features are real or not. And here's another object here, that drawing that he did and compared to the Messenger, degraded image of the Messenger. This is the same part of the surface, so it's trying to see any similarity, like in figure number 5, that you keep seeing it, and probably you can see it, but it's not definite proof yet. Okay, it's a little caption that I wrote for him because April 23rd, last April 23rd, Mercury was visible in the evening sky right after sunset, and it will appear exactly the same phase, same longitude, same size, and all. It'd be equivalent to what Schiaparelli saw back in 1882. So we try to encourage observers trying to observe Mercury on April 24 and see what and trying to determine what they see, if they see anything on the disk, on the planet, on the surface or something like that, and trying to compare the drawings that what Schiaparelli did back in 1882. Unfortunately, the weather didn't cooperate for many observers at that day, so we didn't get any observation. So this is one of the projects that we've been doing here. Okay. Now, what I'm trying to show here, that I made a very interesting publication in the journal about the imaging of the surface of Mercury from 69 degrees to 100 degree west longitude. And just to give you an idea, this is the kind of work I do, write about what I saw, what I think, in my opinion, or what I accomplished, anything. If I hit some of the images, so I don't know how well can you see from where you're sitting, but this is taken from last November. This is my images, and this is the images from the Messenger spacecraft. And what you see here is the same surface, and then I made it the same size. And you got the dates here, November 7th, 8th, 14, and 2015, and November 18, 2020. And so you can able to see some of the detail, like ray craters, something like that. And what you see here, these are ray craters. You don't see the crater itself, but you see the effect of the impact. It's very similar to what you see on the moon, like Tycho, Copernicus, and Kepler. You see all these rays. So that's what you see here. And this is 2 rays here, and they all match together. They're all consistent with one another. And here's another shot too. Now this Mercury getting fuller. You can see from half together. You see the ray craters here. There's the same thing here, 3 here, and so forth. This is full. Mercury came to full phase right before superior conjunction. And you can see those white spots you see, those are ray craters. A lot of them. Look, right here, yeah, the bright one right here too. And now here's a close-up of the messenger part of the surface taken by the messenger spacecraft. And that's what I'm trying. These are ray craters. What you see here is visible in the actual telescope. You see these white spots under the field. And these are the names here. Okay, and they identify ray craters in the image. These are the features that can be easily seen in an amateur's telescope. And of course, I made a two image animation. You can see it rotated from left to right. You can see the phase change in even one day. Oh. Here's the sixth image. You can see from like from half to givers, and you can see it is rotated from left to right. Now you don't actually see the rotation of Mercury. You actually see the orbital motion. Because Mercury rotation is about 59 days. As Mercury going around the sun, 88 days. So it's rotated very, very slowly. So. Okay, next one is a full phase. You can see the 2 days apart. You can see it's rotating from left to right. You see all the features moving across. Okay, how I did this? Well, I have a black and white camera. Images source, DMK, 41AU16AS. The black and white, this camera is about 10 years old. So this is one of, it's not a very large chip, but it's about 1/4 of the size. And it's very sensitive to the red part of the centrum. So I can do infrared imaging with it with the red filter and all. So it's got a very well spectral response at that wavelength. And of course, they can do blue light, like ultraviolet light imaging of Venus. And then I use the IC capture software in order to capture the image. And then I use the Racket Stack 6 for the black and white image. And once I upload it, after I uploaded the images, and then what I got to do here to Racket Stack to stack the images. So that's what it looks like. See, now you can see this Mercury looks like a small disk and all. Forget it's very, very small. So you need very high magnification. Okay, so what I did is to, okay, and now you want to make sure it's stacked them. I put, marks there. So when they stack them, that's why it can be stacking exactly one top of another. Okay, once it's done, okay, so it's not much different, but now it's stacked. Probably, I don't remember correctly, maybe 50% of all total images that I did. And I used the 50% best images being stacked. Okay, now the next step, AstroSurface. That's when I can process after it's being stacked and transferred to the AstroSurface surface software. Now, I recommend this for planetary imaging, and I mentioned about 2 years ago, and I really got into this software, but this is one of the best software for planetary processing. And it was recommended one of the Apple members. And this is fairly new, 2-3 years ago. And then I messaged the Ashley group and all, but it seems like not too many people interested. But now it's getting a little more popular. And this is excellent software for, I don't know about Deep Sky. I never tried that, but this is more for planetary processing. Okay, once I open up, now I got the image, so I'm ready to process and to be stacked. And what I did is to wavelength, by pressing this wavelength, and this is, the setup to sharpen the high definition of both definition, and here we go. It's sharpen up. I don't want to sharpen too much, then it's going to look over processed. So you got to be very careful of the delicate details on the surface. So you don't want to do too much processing and trying to do as little as possible without, otherwise you won't bring out much detail, but without going over too much. Now, Now, if it rotates, I like when it's straight here instead of this way or that way, so I like it straight here, so we can able to, identify the features on the surface. Okay, so then I straighten up. Okay, then I crop it. All right, you don't need all this space here. Otherwise, it takes up a lot of memory space on a hard drive. So you want to use this much. Okay, so this is nothing. This is just a waste of space that you want to save. But once you crop it, then, you can have more room in your hard drive. Then once you crop it, here you go. Well, it's dark, but it's right over here. Now, the next up, I see used Richardson and Lucy. This is almost like sharpening. They make sure, it's not being over processed, but just a little sharper. So concentrate here.
What is the term for what you used?
A what?
You said Lucy something, or what was it called?
It used for sharpening.
Oh, okay.
Yeah, used for sharpening. It depends on the pistol. I'm still new to that, but I'm still learning how to do it. Okay, once I do that, now it's a little better. See? That's it. I don't want. That's it. That's where it ends. I don't want to do any more than that. Otherwise, it's going to bring out a lot of detail that will look like artifact and it doesn't look natural. So try not to over process.
Is that
Okay.
halo an artifact?
With that,
It looks like there was a halo. Is that an artifact?
let me see. Let me go back. Be like here, the limp effect, right?
Yeah.
Yeah. That's very hard to get rid of that. I've seen a lot of people have images of that. It's very difficult to. Yeah. I know not all the time I get this, but it's a contrast effect.
What causes that?
It's like, I really don't know. I tried to talk to a lot of people who are doing that. They have trouble too, but not everybody. It's just a contrast effect. It's because it's dark and against the limp, it's very bright and it's very hard.
So that is an artifact of the process.
Yeah, that's part of it. Yes, yeah. But when it's over processed, it gets very bright here.
Oh,
Yeah.
Yeah, Frank, it looks like there are very few pixels to begin with. I think the entire image, including the black part, is less than 200 by 200. There's a couple of frames back, I saw the size.
Yeah.
Not that much to work with anyway.
Yeah, right, yeah. Don't forget, this is also a high magnification, so that's what happens there. But it's very difficult to work with. It's something like you're dealing with a small disk. So, but not all the time it happens. Not all the time. This is the AstroSurface software. This is like a main page. If you're interested, hit the website astrosurface.com /page uk.html. If you're interested, I mean, I haven't tried with the deep sky, but they have some processing with the deep sky object, but this is mainly for planetary. No. This is, they have all the help there, manual, and to give you like some samples how to process the moon, the sun, the deep sky too, and Mars. So these are some of the examples, like show you how to process, how to use this software.
Right,
It's a very interesting.
Is that free software?
Hmm?
Is that free software or do you have to pay for that?
No, it's free.
It's free
software. It's free, yes.
Thank
Yeah. If you want to check it out, hit the website. Up
Yeah.
here. If you want to check it out, if you're interested. Okay. All right. Also, wind tupos. That gives all the planetary information, any planets, whether Mars, Jupiter, Saturn, Uranus, Mercury. So this is, for example, like June 29, 2022. This is what Mercury looks like the day that you observe it. They have all sort of information like central meridian 109. They have all this, whether you want texturing, shading, grid. If you want a grid to show, to identify the, with the longitude and latitude, it will look something like this. And you're able to pinpoint, you know, the certain feature, well, this is 20 degrees north, something like that. And to help you to identify the feature. So it's a very interesting software. If you're a planetary observer or imager, this is right to have. And this is also information at the nearest, and to tell you the longitude, the declination, the right ascension in the sky, that elongation. They have lifetime, they have diameter, phase, and then also visual magnitude, anything that you want to know that the day you're observing. Okay, last Jupiter, June, July, morning apparition was stunning. It hit some of the shock here from June 19th. Mercury was cleansing that time. And also able to see, now you see the face here, and this is from the Messenger spacecraft, and this is my image, and then you can able to make it out some ray craters, They're very bright, they have enough contrast to see.
That's astounding. that
Yeah.
You pull that detail out.
Yeah, well, here's this one, for example. You see all this white ray craters? It's this one right here. And this
Wow.
one represents down
Yeah,
here. And this one here is this here. So look at this. So, don't forget, this would take in the daylight with Mercury much higher in the sky.
Yeah.
That's the best way to do it. Not when it's very low, when it's a lot of air turbulence. It's very, very bright. It's overwhelming, the brightness. But Mercury is so much easier to see in the daylight. It has a high surface of brightness, so it takes up the high magnification really well. You know, you don't want to observe Mercury when it's too close to the sun. Usually on a reasonable elongation, like near the greatest distance from the sun, like maybe like 20 degrees to 25 degrees away from the sun. So that's pretty much a safe distance. And of course, you know, you put the telescope in the shade and the sun is being blocked by the roof of the house, then you have a very short window opportunity to catch Mercury. And you have to be really quick. So. Here's another shot by another person, which I helped him from Florida, from Southern Florida, and I encouraged him the image of Mercury. Then you got some fine shots, yeah. And I'll just give you an example of that, what I'm doing when people send me the observation. Okay, there's another fine shot here, and there's another shot here. This one is when, let me see. Okay, well, this is one shot here, and then there's another time here, and this is what they observed on July 4th. July 4th. But believe me, it looked a lot better on the computer monitor. This is another shot by a guy here from Florida, and this is Messenger, and this is, you can see some of the details that he captured. There's two here, there. Okay, and so, and I can able to identify with all these ray craters here, you know, this number here represents, this is this number here, 3, represents this one here. So you can able to match one another. Okay, and this one is, okay, this is my picture, and this is the guy from Florida. And we both took images of the Mercury at the same time on July 4th, and you can able to match the detail quite clearly. Yeah, you know, like there's two ray craters here, this one right here, and this one right there, this one here, this one here, this one right here, that's the bright one there. And of course, I made an animation. You can see when it's crescent to full, and you can see all the features move from left to right. So that's the best way to do is show the animation, because the details are very faint and subtle, and it's more eye-catching this way to watch the features move across the disk. Okay, final message. The outdoor Mercury session will continue to collect observations like I'm doing every year. And how many more ejected ray craters worldwide can be seen at the telescope? I'll just show some of them, but there are many more. And what are the brightest ray craters visible at certain longitude? And so far, the two brightest rated craters are Ellerton and Diffuse. Both are, but there's one more. And Cooper crater, one I just showed you, might be the brightest. It depends on the solar angle I see from Earth. Well, if it's too close to the terminator, it may be a little dim, or if it's more centered of the disk, it might be brighter because you got a very high reflectivity, or if it's closer to the limb, it may not reflect much light from there. So it depends on the angle. Okay, still more work needs to be done. Okay, now keep observing Mercury if you have this year. Okay, now this is the end of now. This is part 2. All right, this is a little shorter than now. Part 2 will be the title. It's not. That's not the comet. All right. Well, it looks like a comet, right? Well, this is something new now for amateurs. That's like an open up the new chapter of observing, not observing, but imaging Mercury. But let me go on. I will explain. Now, that is not a comet, but this is not a comet either. But this is one classic car that you want to own. The 1963 Mercury Comet convertible. This car you will love to drive. You will love to have it. But, yeah. So I've seen this car before. It's a really beauty. It's a classic. So no, it's called a Mercury Comet. But anyway. That is the comet. Okay, probably many of you remember Comet Hale-Bopp back in 1997, and it's visible brightly right after sunset. Here's some of the shots I did here. You can see the dust tail, the iron tail, and so forth. Also the next shot, and just a couple of years ago, Comet Wide, not the comet, right? So it was visible right after sunrise. And so this is one of the shots I did, and then this is a shot I did a couple of days later, a week later, July 16, 2020, right after sunset. That's the comet. So that it's a comet. It was made up of frozen gas. It's like a dirty snowball made of frozen gas. And what you see here is the tail, right? The sun is shining from your lower left. And push all the gas, iron tail, dust away from the head of the comet. So it will form a tail. Okay. That is the comet, right? I want it nice tail. But the comet Mercury. There it is. It's a Mercury. It's done by Andrea Alessandrini, the Italian amateur astronomer, and he sent it to me, and here I guess a picture of the comet's Mercury tail. This is something new at that time, but it was well known at this point. Anyway, he captured with a small refractor. I don't have information at home. It's a small refractor you employ with a sodium filter, and I'll explain that. And but I have several more shots, and yeah, Mercury sodium tail photo by an amateur. Okay, our own Theo Bellavia, he took it last year too. It's one of the fine shot here. Not only that, he got the nearby Crescent Moon and this Mercury here, and I guess he's not on it. I don't think he's on it though.
Not tonight.
Went to Cherry Spring, right? Whatever. Yeah, well, he's not on. So anyway, it's a close up with all the processing, and the tail comes up right here. Okay, here's another shot. It's a close up shot. He did it last April. Beautiful. Here's what the comet is. It's just like a comet. It's right here. It's amazing. It really is. It's really amazing. Okay, here's another fine shot by a friend of mine, John Bandra, from Massachusetts. Just like very similar to Steve Bellavia. Steve near the tail here. Now hit the Pleiades. Now, that's a very nice shot because you have the Pleiades and you have Mercury with the sodium tail. Now, this is good in a way, you can be able to tell how long the tail is by compare how big of the star cluster. My best guess is the way the Pleiades, the side of Pleiades with Mercury, it seems to be approximately 1 degree tail. Maybe 1.5 degrees, something like that. And I can follow up, and the computer monitor, the screen monitor able to see a little bit. It looked like from here, but I can able to trace it out. So it's about 1.5 degrees the most.
Frank,
Yes.
you know how many miles that 1 degree translates?
A lot. I don't remember offhand, but it's a lot.
What?
Maybe talking about 1,000 miles, maybe more than that.
What, if I may ask, what causes the tail?
Okay, I'm gonna explain
Oh,
that.
okay.
Yeah, I'm gonna explain that. Okay, here's a close-up shot.
Yeah.
That's a very nice shot. Yeah, very nice shot. So this one here, it's very interesting. This is one from the German amateur astronomer. He sent this to me. His name is Sebastian. He's a German amateur astronomer, and he took this from the Canary Islands. Now, you have Mercury here, so now this is now you can see a little bit more because this was taken from the darker sky. Here's the Pleiades here. Now, this would take, I'm going to explain, this would take with the sodium filter. The sodium filter has a band pass where it can emit sodium light and eliminate other parts of the spectrum. And I will explain that. Actually, this is really 2 photographs stitched together. With the sodium filter, you cannot take down Pleiades nebulosity. Okay, this would take me another time, and this would take me the sodium filter with Mercury on the tip. So he stitched it together. But actually, this is the same distance with what he took that night. The same distance, but 2 different filters and 2 different times, and stitched together. They make a very nice composite photograph. Really. Okay, now if you want to see what he did, this is the website. You want to copy it down if you're interested. Look at another time. And it's about 3-minute video. He showed how he captured the Mercury sodium tail from Canary Island. It's very interesting. It's about 3 minutes. If you want to copy it down, I'll leave it for a couple of just for a minute. And it's like I said, the sodium Mercury, it's been known for quite a while, but now to get the amateur astronomers get involved using the sodium filter, which I will show you in a minute. Okay, I don't know if anybody will copy it down. Any more
Yeah,
time?
yeah.
Yeah, okay.
Thank you.
Okay, all right. Okay, all right, now we're going to talk about it. This is Mercury sodium tail. This is taken from the Messenger spacecraft. You got a 3rd flyby and you got a 2nd flyby. Now here's the sodium here, and here's the, now, we all know that it seems like Mercury had the atmosphere. No, not as we know of, but it contained sodium molecules in an exosphere. Now, all planets have exosphere, but Mercury has just 1 layer of atmosphere. It's not really an atmosphere, but it's just a layer with a lot of gas molecules being scattered around the surface. Of course, Mercury doesn't have an atmosphere, but it contains an exosphere and has a lot of sodium molecule bouncing off around the surface due to the solar radiation. Now, the next image you can see here, this represents the Mercury here, and you can see the tail here, and the sun is on your left it pushes with the solar radiation, it pushes all the gas and sodium molecules away and form like a tail. Now you can see here, these are the shadow, Mercury shadow projected on the sodium gas. This represents the Mercury, the surface.
And that's from Messenger?
Yes, that's for the messenger spacecraft, yeah, but able to image, they have a software filter where you can image the sodium light. Now, amateur astronomer can do the same thing, and I just showed you before. Okay, now this is a short animation. You can see that at one moment it's just like it's not showing much, and the next moment you see it being very intense. You can see at Mercury going around the sun, and don't forget they have the perihelion, you got a billion, Mercury close to the sun here, and Mercury further away from the sun here, is elliptical orbit. Well, we're just trying to show you, you can see at Mercury going around the sun, and you can see the the intensity of the sodium tail. It gets narrow, it gets intensified, and smaller, and then goes around the sun. So when it's close to the sun, you can see that it intensifies and you can see it gets very strong, very intense rays. Yeah, going around.
Frank, that says on the top TAA and it goes through 360. What is that?
Yeah, I think it's the orbital longitude, not the longitude of the orbit.
Oh, okay.
Yeah. So the 360 degrees.
Right.
360 right here.
Oh, there's a purple thing. I didn't see that. Right.
Yeah,
Thank you.
Yeah, right here.
I
Yeah.
didn't see the first thing.
Yeah.
Frank, the tail seems to fade both at the furthest point and at the closest point. I was-
Yeah, one of the furthest way it gets dimmer.
Right.
Yeah, it
Why-
gets closer.
why? It gets bigger, but
Yeah,
it fades now at the closest point.
Yeah,
yeah. When it fades out here, when it reaches here, yeah, it's fade. I don't understand.
Does the tail change based on solar activity?
We don't know yet. This is the temperature, but Mercury, as Mercury gets close to the sun, it tends to solarization, it picks up more solarization.
Yeah.
So that's why the sodium, the tail, they get more intensified and it get pushed away from the solar winds. But this is one of the examples I've seen.
I'm moving away from the candle.
Yeah. Okay, now this is the spectrum. Now the sodium light emits at 590 nanometers right here. It's the double line here. So this is where it emits light. Now with the filter, I'm going to show you that it emits just this portion of the spectrum, and eliminate the other. So the only sodium light goes through, and that's why you can able to detect the sodium tail, which help to increase the contrast and get the sodium light on for the camera. So this is a very sensitive part here, because this is what we see here. This is close to the yellow light, and it's very sensitive to our eyes. So that's why we can able to see the sodium light a lot clearer. Okay, well, this is the core section of Mercury. You can see that it contains other gases too, not only the sodium, but we've got oxygen, hydrogen, helium, potassium, all around the surface. So it's not considered atmosphere, but it got molecules around it. Now, we only can see the sodium really well because our eyes is very sensitive to it. Yellow light, because sodium emits yellow light. So that's why our eyes are sensitive. But these are very being washed out. They're there too, but it's being washed out by the sodium light. Yeah, okay. John, I think, John, you asked me about the length
Yeah,
of it.
this part,
Okay,
yeah.
yeah. It has the length of 2 million kilometers.
Jesus.
So if you convert it to miles,
Yeah.
I don't remember offhand.
It's around 1.5 miles roughly.
Okay, All right, so that could be part of the answer.
Right. Yeah.
Okay, and the next one is, okay, just to give you an example that, with solar radiation with mercury, you can see all the sodium gland and form like a counter tap. So. Okay, during the transit, most of the major observatory are trying to detect to see if they pick up any sodium molecules around this mercury limb. Now, during the transit, this is a very high magnification, and if you look carefully, you can. I don't know if you can able to see around the limb. You see like a little blur there. That's probably the absorption of the sodium light. So I don't know if that. I don't know if they're able to detect that, but so it's not yet conclusive yet. So this is one way to find out if it can be detected, the sodium molecules around Mercury. Now, this is like the same way for the exoplanet. When it transits its own star and it gets dimmer, and you're able to, with using the spectrum, you're able to detect whether or not it's exoplanet consists any atmosphere, and you can pick up the molecules. It's the same way to see if sodium molecule can be detected. We know it's there, but we know if it can be detected in doing the transit.
Frank, do you know what solar scope that was?
I don't know. It's one from a major observatory. Yeah. Well, you can see the granules.
Yeah, it's very.
I wonder if that's Hawaii, they in a way.
National Solar Telescope, TIO, yeah. This was taken May 9th, 2016. Yes, 2016 transit.
And it said TIO?
TIO. Yeah, TIO, yes.
Huh.
I think SST, the National Solar Telescope. Yeah. Okay, now not only Mercury, but even the moon. Our moon consists of solar molecules around. All right, this was taken with Boston University space physicists to September 30th, 1991 from McDonald Observatory. Now they're able to detect sodium molecule around the moon too, but we don't see the tell. They can see the effect of it. Don't forget, we're much further away from the sun, so it doesn't produce a lot of sodium tail like we see in Mercury, because Mercury is so close to the sun. But not only the moon too, but even Io, Jupiter moon Io consists some sodium. And they detected the tail, but it's very, very faint. I mean, it's much further away from the sun than we are, and they have a very weak sodium tail. So I guess it's pretty much common in our solar system. Yeah. That's interesting. Okay, now even the Earth has 5, we all know that the Earth has 5 layers in the atmosphere. We have troposphere, we have stratosphere, we have mesosphere, we have thermosphere, and exosphere. This is what Mercury has, exosphere. It's a extreme outer limit, outer layer of the atmosphere. So, okay, this is, for example, right, this is the troposphere, this is the atmosphere that we live. And a little further up, they come the stratosphere, and they have most of the high cloud airplanes, they fly in this layer. And mesosphere, which is the third one, that's where most of the meteor burn up when they enter the atmosphere, and they part of the layer. And further up, you have a thermosphere, and most of the satellites get informed. Then an exosphere, a lot of astronauts, they up there with big telescope and there. And this has got very contained. More further up, you got, even though they call it exosphere, they consist of very few molecules that are being attracted by the gravity of the planet. So that's what Mercury has. Okay, and then if you go beyond that, then it's considered of nothing. So this is one of the examples that the Earth has the exosphere too, just like Mercury. Okay, now this is the filter that being used for capture the sodium tail. Now this is phone lamps and filter with 590 nanometers, that's the very advanced, that's where they use to capture the tail. Now, here, the 590 with 2 nanometers, so it's pretty narrow. So you need a good time closer. So what you need, you don't need a very large telescope. It's just like like Steve did, Bellavia. He had like a small telescope. I think it was a 90mm bulk. That's all you need. It's like a small refractor telescope using a filter like this. You screw it on the camera lens between the camera and the telephoto lens or telescope, and you take time exposure, but not necessarily have to be long. But just short enough if you have it on a tripod without tracking, and then you have to stack them, or you can be able to track it at Mercury. Let's say you don't want to capture the sodium tail when it gets too low on the horizon, because otherwise it will be all washed out. And you don't want to take when it's high in the sky, when the sky is still light, then it will be washed out. You have to capture the right moment. I think if I remember correctly, it's usually about 30 to 45 minutes after sunset. When the sky gets reasonably dark, at the same time, Mercury is still high in the sky. And also, usually in the spring, evening apparition, usually the best, because Mercury is in perihelion to the sun, and the closest to the sun at that time, and you get a very intense sodium tail that you can be seen. Unfortunately, on the downside, it's close to the sun, but yet it's getting set right away after sundown. So it's got a very short window opportunity to do something like that. So you got to capture the right moment too. And not only this Thornland, but other company like Edmund optic lamp from New Jersey. Yeah, they sell sodium filter also. They're not very expensive. I mean, you're not talking about $200-300, but this one talking $155. Some other filters, more narrow band pass or something like that, cost a lot more money. I think about getting one too, and so hopefully get around to it, like able to do it. But I don't have a small refractor, but I do have a telephoto lens, but I don't know how good it is. Okay, now Mercury is famous for not a cometless. Anyway, that's at the end. So if you ever think about going somewhere where it's really, really nice and hot, and you go to the travel agency, I recommend Mercury is a good place to go. All right, so that's it.
Great talk, Frank, as always. That's astounding,
Yeah.
really.
Thank you. Anybody have question? Anybody on the computer land? No. All right. That's about it, though.
Frank,
Yeah.
Here, let's,
does,
okay.
does your astronomical camera
Mhm.
have its own focal length, or is it based on the focal length of the telescope?
The focal length of the telescope. Yeah.
Thank you.
For image of Mercury, I used a 2 times Barlow lens increase. It's just double the magnification. Don't forget, Mercury is a small planet, so you need high magnification. And a good scene too. The sky has to be clear transparency. And you don't want any clouds around, otherwise it will be kind of washed out. But if you plan ahead enough to try to image like Mercury did, you have to plan in advance. You got to know where Mercury will be the day that you want to observe. You don't want to be too close to the sun. Make sure the weather's good. Make sure it's not windy. So you got to consider all of that. And so that was the fine week when I did last November 2020 and last June. That week we have we had a long stretch of fine weather and good sea at the same time. So.
Thank you.
Let me have- oh.